today we are conducting 20th session of 20th episode of our online problem solving sessions for JAM and NET aspirants. Today we have Mr. Athul is with us to handle a session on vector calculus. Athul completed his MSc from Central University of Hyderabad and qualified GATE and now working as a guest faculty at PRNSS College, Matanur. So I hope that today's session will be really fruitful because all of you know that JAM examination is on February 14th and there are many questions from the area of vector analysis, vector differential calculus and vector integral calculus are used to ask for JAM exam, also for GATE exam. So today Atul will explore some of the questions from the previous papers of JAM exam and GATE exam. I welcome all of you to this event and hope that the session will be really fruitful to all of you. And I would like to express my sincere gratitude to Mr. Athul for accepting our invitation and joining with us with a request on a short period. I just asked Athul only around 1 week before to arrange such a session. So very much I express my sincere thanks to him on behalf of Math Aspirants WhatsApp group. So once again, welcome all of you to the event and hope that the session will be really nice for all of you. Wishing you all success in your exams. Thank you everyone. Over to Athul.
I'm also very happy to be a part of this program and all the best for the maths aspirant team. So I think we will discuss vector calculus today. I hope all of you had done a course on vector calculus, means vector differential calculus and vector integral calculus. So this vector calculus can be seen as a part of multivariable calculus, mostly the analysis part of that. But actually the difference between multivariable calculus and vector calculus is completely based on the physical things. That means it is mostly related to physics. It handles vectors on plane and spaces. The general multivariable calculus is a generalized version of that, which deals with n-dimensional spaces, which is actually for physics people, it is actually some kind of abstractness. So this vector calculus is very important for JAM aspirants because it is a part of their syllabus, and it is once you know the main results in vector calculus, you can easily crack those questions. So that is the speciality of vector calculus. But sometimes some questions may take time to calculate things. But if you are good with integration, the usual integration, then it will be easy. And by doing more and more questions, you will be familiar with the tricks. So answering those questions will be really easy. Also, for GATE exams, vector calculus is there in the syllabus. Almost the same syllabus is following for JAM and GATE. So these questions I have collected mostly the questions from JAM question papers, previous year's JAM question papers. Also, this will be helpful for GATE aspirants. So without wasting much time, let us move on to the questions. And I will not discuss the most part of the theory because it will take time. So as we are seeing each and every questions, we can discuss the theory part behind that, so that it will be easy to get the theory and do the problem. So, okay. Once again, thank you, Vinod sir, for giving me a chance to handle this session. So, we can move on to the questions. So, we will start from the basics of vector calculus to the most important theorems, such as Green's theorem, divergence theorem, and Stokes theorem. So this is how I have arranged the questions. So that will be like a revision of vector calculus again. So the first question is, let the vector r is equal to xi plus yj plus zk, and simply r denotes the modulus of that vector. If f of r is a function defined as log r, and g of r is defined as 1 by r, those are scalar functions where r not equal to 0. For defining g of r equal to 1 by r, we need r not equal to 0. And these two functions satisfy 2 times del f is 2 times del f plus h of r times del g is equal to 0 vector. Then the value of h of r, the function h of r, is what is the function h of r? So that's the question. So once again, r is given as the vector xi plus yj plus zk, and simply the r denotes modulus of r vector. There are two functions defined, f of r is log r and g of r is 1 by r for r not equal to 0. And it is given that those two functions satisfy 2 times delta f, sorry, 2 times del f plus h of r times del g is equal to the 0 vector. Then what is the function h of r here? So that is the question. So for this question, let us recall some things in vector calculus. So I have listed something from the vector calculus, some results or some basic definitions of vector calculus. If vector A is given as a1i plus a2j plus a3k, then modulus of that vector, or it is called as sometimes it is called as magnitude, length, or sometimes people call it as norm. So whatever it is, modulus of that vector is given by square root of a1 square plus a2 square plus a3 square. And we will discuss only, as I was telling, we'll discuss only for vectors on R2 and R3, the plane and the space. So don't worry about that. So this will be the modulus for plane. The vector on the plane, you will have two coordinates, a equal to a1i plus a2j. For that vector, its modulus will be square root of a1 square plus a2 square. Okay, this is the usual Euclidean norm on R3 or R2, whatever it is. And del denotes the gradient operator, which is dou by dou xi plus dou by dou yj plus dou by dou zk. Okay, and for any scalar field means it is a scalar valued function, just a function defined on R3 to R. Okay, scalar valued function. For such a function or such a scalar field, del f, the gradient of f is dou f by dou xi plus dou f by dou yj plus dou f by dou zk, and it is called the gradient of f. And gradient of f is sometimes denoted as grad f also. So in some question paper, you may see del f, or in some other question papers you can see grad f. So both are same, both are the same. So these are the things mainly you have to use in this question or to solve this question. So I think you can now try to solve this question and find out the answer.
Hello, Athul.
Sir.
Someone are answering in the chat box.
Yeah,
We
I
can
can I can
see
see.
that.
I can see that.
Oh, okay, okay.
Yes, most of the people are telling it is option C, 2R. Okay, let us see that. So, so can we go to the answer? Okay, let me ask someone, or let me go to the answer first. So, so this is how you have to do this question. So I think I have given the details here. So R is given as xi plus yj plus zk, and the modulus of this is, as we were telling, it is square root of x square plus y square plus z square, and f of R is log R. Now we have to find out del f, gradient of f. So for that, you just find out dou f. Gradient of f is, as we were telling, dou f by dou xi plus dou f by dou yj plus dou f by dou zk. So for that, you need to find out dou f by dou x, dou f by dou y, dou f by dou z. So I have found out dou f by dou x here, which is dou by dou x of log r. It is 1 by r times dou r by dou x. Dou r by dou x is actually 1 by square root of 1 by 2 1 by 2 times square root of x square plus y square plus z square times 2x. So it is actually 1 by r times 1 by 2r times 2x. So it will be x by r square. So similarly, from this itself, you can guess what are going to be dou f by dou y and dou f by dou z. So you don't need to waste your time by finding out again dou f by dou y and dou f by dou z. So similar calculation is going on there. So you'll get dou f by dou y is y by r square, dou f by dou z is z by r square. So del f is equal to the sum of all these things, which is 1 by r square times xi plus yj plus zk. We know that 1 by xi plus yj plus zk is the vector r. So this del f is equal to 1 by r square times vector r. So now this is g of r. G of r is 1 by r. So dou g by, we need to find out del g. Dou g by dou x is dou by dou x of 1 by r, which is minus 1 by r square dou r by dou x. Again, we know what is dou r by dou x. We have found out there. So it is actually going to be minus 1 by r square times x by r, which is minus x by r cube. So del g is going to be, again, dou g by dou x. We have found out dou g by dou x. So we can get dou g by dou y and dou g by dou z from here. It will be minus y by r cube and minus z by r cube. So del g is minus 1 by r cube times xi plus yj plus zk, which is
Sir, screen is not visible, sir.
so means you cannot see the screen, right?
Yes, sir. I cannot see the screen.
So
See, the screen of Athul. Okay.
sir,
It is from the side. You identify the Athul and you can pin it. Okay. Athul is continue. I think it is visible for others.
okay, sir, okay. So del g, sorry, we have found out del g is minus r vector times 1 by r cube. So then it is given that 2 times del f plus h of r times del g is equal to 0 vector. So that implies 2 times del f, we have found out it is r vector by r square plus h of r times minus r vector by r cube. See, minus r vector by r cube means minus 1 by r cube times r vector. So that is equal to the 0 vector. So you can take vector means you can split it into vector and scalar. So it is r vector times the scalar is 2 minus h of r times 1 by r. So that is actually by you can take 1 by r square commonly out from both the terms, and then
The
that.
screen is not visible, sir. Please tell me how to see the screen.
Hello.
It's
You
not visible, sir.
rejoin.
It's out.
You just rejoin, then it will be clear. I think.
Okay, sir. Okay.
So Athul, you can continue.
Yeah, yes, sir. Yes, sir. So you will get r vector times 2 minus h of r times 1 by r is equal to the 0 vector. Now it has two possibilities. You cannot cancel r vector or something like this, because once we have ab is equal to 0, if you know a not equal to 0, then there is a possibility of taking b equal to 0. So you can't do that here because you have vector and scalar. So this implies either r equal to 0
Okay,
or
sir. Now visible.
2
Yes,
minus
sir.
h of r, the scalar 2 minus h of r times 1 by r is equal to 0. Now it is given that the vector r is non-zero for the function g. So or r is an arbitrary vector, so you cannot take it as 0 always. So you will get the scalar 2 minus h of r times 1 by r is equal to 0. So that will give you h of r is equal to 2r. So the correct option is C, option C. Is that clear to everybody? Or if you have any?
Yes, sir.
Yes. Okay.
Yes, sir.
Okay, right. So shall we move on to the next question?
Yes, sir. Move on, sir.
Yes. Okay, fine. So the second question is here. Let A is the vector. It is the constant vector I plus j plus k, and R is the vector xi plus yj plus zk. See, actually, R, or whenever you are getting R, vector R, you realize that it is the vector xi plus yj plus zk if it is not mentioned, which is the position vector of the point xyz. Okay, hope you know what is a position vector.
Okay, sir.
Yeah, so this is r is xi plus yj. In some questions, they may simply give r, vector r. So you have to understand it as a position vector. For x, y, and z in r, which of the following is false? So we need to find out the false statement from the following. So the statements are del of a dot r, the vector a dot r is equal to the vector a. Del is the gradient. Del dot a cross r is equal to 0. Del cross the vector a cross r is a, vector a. Del dot a dot r times r is equal to 4 times a dot r. So these are the options. So we need to find out the false statements. So you have to verify each and every statements given here. So before that, let us again go back to the vector calculus. You can see here, if A is the vector given by a1i plus a2j plus a3k, and B is the vector b1i plus b2j plus b3k, then A dot B, the dot product, usual dot product, it is a1 b1 plus a2 b2 plus a3 b3. A cross B is defined as the determinant of ijk, a1 a2 a3, b1 b2 b3. That is what the cross product of the vector product. The previous one is called the scalar product. And delta is already we have defined delta, the gradient. gradient operator actually, delta. Del of f plus g is actually del f plus del g. Del square of f is the del square of f is defined as dou square f by dou x square plus dou square f by dou y square plus dou square f by dou z square, and it is called the Laplacian of f. And the operator del square is called the Laplacian operator. Okay, so these are the things you need to know. So when we have del cross a vector, so you can use the vector del here. So we have defined the vector del here. So that is dou by dou xi plus dou by dou yj plus dou by dou zk. So instead of a1, a2, a3, you can use dou by dou x, dou by dou y, dou by dou z. So that is how you calculate del cross b. Okay. So now we can do this problem.
C, sir.
C. How did you get C? Can you explain?
So first we do the A cross R, then we apply the del cross. That one we can't, that not equal to A vector, sir.
So what you're getting actually for del cross A cross R? Okay, somebody answered it is 2A.
2A vector, sir.
Yes, 2A.
2A,
Correct.
sir.
Yes. Okay, fine. So let us see the answer. So you are telling option C is the false statement, right?
Yes, sir.
Okay.
That is
Okay.
false.
So let us see. Here it is given as A is equal to I plus J plus K, and R is the vector xi plus yj plus zk. A dot R, as we have defined, it will be x plus y plus z. A cross R will be z minus yi plus x minus zj plus y minus xk. Now we'll check by option. So first option was del of A dot R. Del of A dot R is del of x plus y plus z. So it will be dou by dou x of x plus y plus z I plus dou by dou y of x plus y plus z j plus dou by dou z of x plus y plus z k. So that will be I plus j plus k, which is the vector A. Okay, so the first option was del of A dot R is equal to A. So that statement is correct. So option A is a correct statement. Next, option B. Is that option B? Yeah. Del dot A cross R. Del dot A cross R is del dot A cross R. We have already found out z minus y times I plus x minus z times j plus y minus x times k, which will be dou by dou x of z minus y plus dou by dou y of x minus z plus dou by dou z of y minus x. So dou by dou x of z minus y is 0, dou by dou y of x minus z is 0, dou by dou y of dou by dou z of y minus x is 0. So everything is 0. So you're getting 0. Yeah, it is a scalar. It's going to be 0. So option B, the statement in the option B is also true. So now let us move on to option C. which is del cross A cross R. Del cross A cross R is found out here. It will be you will be getting 2i plus 2j plus 2k, which is 2 times a vector, but in option C it is given as a vector, which is not correct, isn't it? Yes, yes, so it is not correct. So that statement in the option C is false. Next, option D, you can see the del dot A dot R times R is del dot X plus Y plus Z times Xi plus Yj plus Zk. I'm not explaining each and every step. On calculation, you will get that is equal to 4 times A dot R, which is the statement given in option D, which is correct. So only the false statements is given in option C. So option C is the answer you have to get. Okay.
Yes, sir.
So hope it is clear, right?
Yes, sir. Clear, sir.
Okay. So let us move on to the next question. So next question is, consider the vector field F, given by Ax plus Y plus AI plus J minus X plus Y K, where A is a constant, small a is a constant. If F dot curl F is equal to 0, then the value of A is. So you have given a vector field and given a condition that F dot curl F is 0, you have to find out value of A. So actually a vector field is
Sir.
what? Okay, again, a vector field is a vector valued function, and it is denoted by capital letters, and the usual vectors are denoted by small letters. A vector field of 3 variables. So it is vector field on R, it's not Rn, it's R3, will be of the form F1i plus F2j plus F3k, where Fi.
Sir, please once again show this question, sir.
Yes, this is the question.
So 1 minute, I return the question.
You can. I'll show you the question, but after explaining this. Okay.
Okay, sir.
Okay. So usually the vector field on R3 is written as F1i plus F2j plus F3k, where Fi is a scalar valued function of variables x1, x2, x3, whatever, 3 variables. Okay. Curl F denotes the circulation density of the vector field F and is defined as curl F is equal to del cross F. You know what is del? We have already defined it. So which is determinant of ijk, dou by dou x, dou by dou y, dou by dou z, f1, f2, f3. And here are some properties of curl F. Curl of f plus g is curl of f plus curl of g, and curl of phi f, where phi is a scalar field. Scalar field means it's a scalar valued function on R3. So curl of phi f is equal to del cross phi f, which is del phi. Del phi is gradient of phi. Del phi cross f plus phi times del cross f. So this is another property of curl F. And curl of gradient of f, that is del cross del f, is always 0 vector. Curl of gradient of f. You can remember that curl of gradient of f is always 0 vector. So those are the properties of curl F. So now you can do the question. You can write the question from here.
Option C, sir.
Option C. Yeah, let us see that. So okay. So can you explain that? What did you get for what was that? F dot curl F. What is curl F?
Sir, it's minus I plus j minus k.
Minus I plus j minus k. Okay. So f dot curl f will be
Minus a x into 1 minus a plus 1 minus a.
x into 1 minus a. Okay, fine. Yes. So then you will get it is equal to 1, right? A equal to 1. Okay, fine. So can we move on to the answer?
Yes, sir.
Okay, fine. So here is your answer. So curl f is here x plus y plus a times I plus j minus x plus x plus yk. So curl f is del cross f, which is given here. You will get it as minus I plus j minus k. Then f dot curl f is going to be the dot product. You can just find the dot product. You will get 1 minus a times x plus 1 minus a. So we have given that f dot curl f is equal to 0. So therefore, you will get 1 minus a times x plus 1 minus a equal to 0. That implies 1 minus a equal to 0, which will give you the value of a as 1. Okay, so option C is correct. So that was a very simple question. Okay, so I hope it is clear. No more
Yes, sir.
explanation is needed. So let us move on to the next question. Okay, so this is the next question. So if f of xyz is equal to x square y plus y square z plus z square x for all x, y, z in R3, so this is a scalar field. And del, you know what is del, the gradient operator. Then the value of del dot del cross del f plus del dot del f at the point 1, 1, 1. You need to find out the value of del dot del cross del f plus del dot del f at the point 1, 1, 1. So find out the value of del dot del cross del f plus del dot del f. Then after that, you just supply the value for x, y, and z as 1, 1, 1. So you will get the value.
Yes, sir. I will try it, sir.
Okay, right.
Sir, its answer is C, sir. 6.
C. Okay, okay, fine. So let everybody try that. Okay, let us wait for some time. So I am getting responses only from a few students. Okay, I think some of you got the answer already. So let us move on to the answer. Before that, uh, we have we have seen del dot some vector field here. So you can see what is that. The flux density or divergence of a vector field, uh, which is denoted by div f, and it is given by del dot f. So that del dot f is the divergence of the vector field. And there is a result on divergence and curl. That is, divergence of curl of f is always 0. Divergence of curl of f is always 0. You can see here we have one part of the question is del dot del cross del f. You know that del f, this del f is a vector field. So del cross del f is the curl of del f. Okay, del cross del f is the curl of the vector field del f. So del dot del cross del f is a divergence of curl of some vector field, which is del f. So that will be 0 by this result. So remember that divergence of curl f is always 0. Before that, we had some result on curl of gradient of f is 0. So curl of gradient of f is a 0 vector, and divergence of curl of f is 0. Okay, so remember those two results, then it will be easy. So let us see the question. So one part is already solved, so you need to find out the other one. So yeah, I have explained here. Del f is a vector field, so del dot del cross del f is 0 always. So you don't need to worry about del dot del cross del f. So you need to worry about del dot del f. So del dot del f, I have found out del f here. It is 2xy plus z square I plus x square plus 2yz j plus y square plus 2zxk. So del dot del f is going to be 2y plus 2z plus 2x, which is 2 times x plus y plus z. So 2 times x plus y plus z will give you the value 2 plus 2 plus 2, which is 6 at the point 1, 1, 1. So as I was telling, you don't need to worry about del dot del cross del f. Okay. So the answer, final answer is 6. The option C is the correct option. Is that clear? So if you have any problem in that, then you can ask me now. Yeah, I hope it is clear for all of you, right? So let us move on to the next question. Okay, next question is the value of C for which there existed twice differentiable vector field F with curl F is equal to 2xi minus 7yj plus cz key. The value of C, constant C, for which there exists a twice differentiable vector field F with curl F is equal to 2xi minus 7yj plus cz key.
Yes. C option, sir. 5.
Option C. Okay. Okay, let us see. Okay, can you tell me how did you get that?
So curl of F already given, sir.
Yes, fine.
And they mentioned in question that they existed twice differentiable vector field of F
Yeah,
vector. We already know one note that the divergence of curl of vector is equal to 0,
correct.
and they given curl of F vector is equal to 0. Then we find the divergence of that given vector. Then we solving, we get C is equal to 5.
Means you found out the divergence of curl F, right?
Yes, sir.
Yes, then equated to 0.
Yes, sir.
Correct. Very good, very good. So let us see the answer. So here it is. So here, as he was telling, we have to use the fact that divergence of curl F is 0. Uh, this is possible because it is given that F is a twice differentiable vector field. Because for finding out curl F, you have to differentiate each and every component of F once. So again, for finding divergence of curl F, already for curl F, you have differentiated it for once. Now to find out divergence of that, you have to differentiate each and every component of F once again. So that means you have to differentiate it twice to find out divergence of curl F. So if the vector field, the components of the vector fields are not twice differentiable, you cannot do that. So that is why they have given F is a twice differentiable vector field. So since F is twice differentiable vector field, you can find out divergence of curl F. So curl F is already given as 2xi minus 7yj plus czk. So divergence of curl F is del dot 2xi minus 7yj plus czk, which is 2 minus 7 plus c, which is c minus 5. So you know that divergence of curl F is always 0. So c minus 5 is 0. So that implies c equal to 5. So the correct option is C. It's not Ci, it is C. Okay. Right. So it is clear, right?
Yes, sir.
Okay, fine.
Yes, sir.
Yeah, right. So that's why I'm telling you need to remember all such small results. Curl of gradient is 0 and divergence of curl is 0. All those things. Okay. So next question. Let F from R3 to R be a scalar field, and vector V is a vector field, and let vector A is a vector in constant vector in R3. If vector R represents the position vector is xi plus yj plus zk, as I was mentioning earlier, then which one of the following is false? Again, you have to find out the false statement from the following. Okay. So
Yes, sir.
okay, so these are the statements. Curl of f times vector v, the vector field, is equal to gradient of f cross v, vector v, plus f times curl of v. That is the first statement. Second statement, divergence of gradient of f is dou square by dou x square plus dou square by dou y square plus dou square by dou z square times f. Next statement, curl of A cross R is 2 times modulus of A times R. And the last option is divergence of R by modulus of R cube is equal to 0 for R not equal to 0. 0 vector. So these are the 4 statements. So you have to find out the false one among these 4. Okay, I'm getting some answers. So some people are telling option C is the false one. Okay, let us see. So, so can we move on to the answer?
Yes, sir.
Okay. Okay, fine. So here is the answer. So yeah, before that, let me, we had stated that result here. So this is a result on curl. Curl of a scalar field times vector field is uh, the gradient of that scalar field cross the vector field plus the scalar field times curl of the vector field. So that is del phi cross f plus phi times del cross f. So this is a result. So that the same statement is given here. Curl of a scalar field times a vector field is equal to gradient of the scalar field cross the vector field plus f times curl of the vector field. So that statement A is correct. So I have given a small calculation of that. Uh, so actually, you can try that. So just write curl of f times v as I j k dou by dou x dou by dou y dou by dou z fv1 fv2 fv3. Instead means we know that the vector field has three components. So here for fv the components are fv1 fv2 fv3. Then find the determinant, and finally you will get gradient. This is equal to gradient of f cross v plus f times curl of v. So the option, the statement in the option A is a correct statement. So next, what was option B? Option B was divergence of gradient of f is uh, del square f. That is actually del square f. So divergence of gradient of f is del dot del f, which is this del dot. Del f is dou f by dou xi, dou f by dou yj, plus dou by dou zk, which is actually dou square f by dou x square plus dou square f by dou y square plus dou square f by dou z square, which is del square f. So option B, in option B also we have a correct statement. Okay, I'm meant by saying option B is true is that the statement given in option B is true, but we want the false statement. Okay, we are looking for a false statement. So now what about curl f? Sorry, this third option, curl of A cross R. Curl of A cross R is given here. Del cross del cross, this is A cross R. The determinant is denotes the A cross R, which is del cross this vector a2z minus a3y blah blah blah. So these calculations you can do, there's no problem. Then del cross that will be given by, finally we get 2 times A vector, but in option C it is given as 2 times modulus of A times R vector, which is not correct. So option C contains a false statement. Okay, so option C is the option which contains a false statement. Now let us look at option D also. Divergence of R by,
Sir,
yeah,
sir, I have one doubt, sir.
yeah, tell me.
So what is the difference between mod A vector and common A vector, sir? They sometimes given in the exam the mod A vector equal to A vector like that.
Mod A vector. Mod A vector means I am not getting what is mod A vector.
Sir, in the third C option,
Yeah.
um, Yes,
See,
sir. There
that is not mod A vector. That is modulus of the vector A. Modulus of vector A.
Okay, sir.
Okay,
So
modulus
what
of
is the difference?
yeah. So in vector, a vector means in physics. I'm talking about the vector in physics.
Okay, sir.
Vector is a quantity which has both magnitude and direction, right?
Yes, sir.
So modulus of vector A denotes the magnitude of the vector.
Sir.
Okay, so it is a
Okay, sir.
scalar quantity. It is a real number. It's a positive real number. Modulus of A vector.
Okay, sir.
Okay, the other one is the actual vector, which has both the direction and magnitude. So that cannot be equal to the modulus value,
Okay,
right?
sir.
So
Okay,
modulus
sir.
of A vector is never equal to A vector.
Sir.
Okay, right.
Thank you, sir.
Okay, fine. Welcome. So next, D, you have to find out the divergence of vector R by modulus of R cube. So modulus of R cube means modulus of vector R, the cube. So that is equal to del dot R vector R by R cube. I'm calling modulus of the vector R as simply R, which is square root of x square plus y square plus z square. I think you can do this calculation. It's just a dot product and finding the partial derivatives. So again, for this kind of questions, once you do the or once you differentiate the first coordinate, definitely you can guess what are the second and third coordinate derivatives of second and third coordinates. So try to do that. Try to find it out. So here I am getting dou by dou x of x by r cube as 1 by r cube minus 3x square by r raised to 5. Again, dou by dou y of the second coordinate y by r cube will be 1 by r cube minus 3 y square by r raised to 5, and dou by dou z of z by r cube will be 1 by r cube minus 3 z cube. Z cube, it's not z cube, it's z square. It's my mistake. 3z square by r raised to 5. So clubbing all of those things, you will get divergence of r by r cube is 3 by r cube minus 3 by r raised to 5 times x square plus y square plus z square. You know that r is equal to square root of x square plus y square plus z square. So x square plus y square plus z square is nothing but r square. So 3 by r cube minus 3 by r raised to 5 into r square, that we will get 3 by r cube minus 3 by r cube, which is 0. It's not 0 vector, it is 0. Simply 0. Okay, so we are getting 0. So option D is a statement in option D is also a true statement. See here, you can see the option D is r by r cube. The divergence of r by r cube is equal to 0. So the correct option, the option that you need is C. The correct option is C. So C is the only option which contains the false statement. Okay. So I hope again that has solved your problem, right? So let us move on to the next question. Okay. So this is the next question. Consider the vector field F is equal to r raised to beta times yi minus xj, where beta is a real number and r is the vector xi plus yj, and simply the r denotes the modulus of r, modulus of the vector r, or magnitude of the vector r. If the absolute value of the line integral over cf dot dr along the closed curve c given by x square plus y square minus a square oriented counterclockwise is 2 pi, then the value of beta is. So it is given that absolute value of the line integral along this particular curve is 2 pi, then you are asked to find out the value of beta. So let us recall what are line integrals first. Line integral of a scalar field. To integrate a continuous scalar field f of xyz over a curve C, we have to proceed in the following steps. So you remember these two steps. First thing is to find out a smooth parameterization of the given curve, which is usually of the form r of t is equal to x of ti plus y of tj plus z of tk, where a less than or equal to t less than or equal to b. After that, evaluate the line integral in the following way. Integral over CF ds is equal to integral a to b f of x of t, y of t, z of t times modulus of v of t dt, where the vector v of t, the vector field v of t is equal to dr by dt, the derivative, the dr by dt. That means dx by dt I plus dy by dt j plus dz by dt k. So that is what line integral of a scalar field. Line integral of a vector field, again you have to do it in two steps. Find a smooth parameterization for the curve, and after that the required integral is integral a to b f dot dr. Again dr is equal to dr by dt times dt, which is dx by dt I plus dx by dt j plus dx by dt k times dt. So you will get dx dy dz with respect to t. So that is how you find out line integral of a vector field. So here you have a vector field, so you have to find out the absolute value of the line integral and equate it to 2 pi and find the value of beta. Okay. So any answer? Okay, let us move on to the answer. So this is the answer is here. First, we have to find the smooth parameterization, as we were telling. The curve given is x square plus y square minus a square, which is r of theta is equal to the parameterization of that is actually r of theta is equal to r cos theta I, sorry, a cos theta I plus a sin theta j for 0 less than or equal to theta less than or equal to 2 pi. That is the parameterization for circle with radius a. Okay, so dr, you are getting dr is again you have to differentiate two coordinates of r with respect to theta. You will get minus a sin theta I plus a cos theta j. As I was telling, dr is actually dr by dt times dt. So that is the way to find out dr. It will be a vector. So and r is the magnitude of the vector r, which is so you will get the square root of a square cos square theta plus a square sin square theta, which is equal to square root of a square, which is a. So f under this parameterization. Now you have to find out, or you have, yeah, you have to find out what is f under this parameterization. That means you have to replace y and x using the values, or the using the parameter. You have to change the values of x and y using the parameter. So here the value of x under this parameterization, value of x is cos theta and value of y is sin theta. That is how you parameterize a circle. X equal to cos theta, y equal to sin theta. So you know that f is r raised to beta times yi minus xj, which is you know that r is actually modulus of r, modulus of the vector or magnitude of the vector r, which is a. We have just found out a raised to beta times y is a sin theta I minus a cos theta j. Okay, so we have found f under the parameterization. Now you can find out f dot dr. F dot dr is a raised to beta times a sin theta dot this blah blah blah. So that will give you finally a raised to beta plus 2 times minus sin square theta minus cos square theta, which is minus a raised to beta plus 2. So therefore integral over c f dot dr is equal to, you can find out the value of integral. It's easy because no term in theta involved here. So it is 0 to 2 pi, integral 0 to 2 pi minus a raised to beta plus 2 d theta is equal to minus a raised to beta plus 2 times 2 pi. So the modulus value of the integral is given as 2 pi. So you will get, so here the value of integral is given by minus a raised to beta plus 2 times 2 pi. Its modulus is a raised to beta plus 2 times 2 pi. But in the question, it is given as the modulus is equal to 2 pi. So you have, while we are equating, you will get a raised to beta plus 2 times 2 pi is equal to 2 pi. So you will get a raised to beta plus 2 is equal to 1. So that implies beta equal to minus 2. So the value of beta is minus 2. Okay. Yes. Okay. Is that clear?
Yes, sir.
Okay. Fine. Thank you. So yes. So that's it. So the thing is, you need to know how to parameterize this given curve. Okay, that is the only thing you have to remember in line integrals. So let us move on to the next question. Yeah, it is here. Let f be the vector field given by square root of xi plus x plus y cube j for x and y greater than or equal to 0, and vector r is given by xi plus yj. Then the value of the line integral over c f dot dr from from the point 0, 0 to the point 1, 1 along the path c given by x equal to t square, y equal to t cube for 0 less than or equal to t less than or equal to 1 is dash. So it's a numerical answer type question. So you have to find out the value of the integral, line integral. That's it. Yeah. So you can do that. So again, there is nothing to tell more because you have already seen how to find the line integral. So it's the same way. The same way you have to find out the line integral. Okay. So can we move on to the answer? Yeah, I have seen somebody got an answer. It is 1.5. Okay, let us see. Okay, let us see the answer. So here you don't need to parameterize the surface, parameterize the curve, because the curve is given in a parametric form, which is x equal to t square, y equal to t cube, where 0 less than or equal to t less than or equal to 1. So under this parameterization, the parametric form of the curve is r of t is equal to t square I plus t cube j for 0 less than or equal to t less than or equal to 1, and the value of dr is 2ti plus 3t square j. Now, as we were telling earlier, we have to represent f in terms of the parameterization. F is given by square root of xi plus x plus y cube j, which is equal to I know x is t square, so it is ti plus t square plus t raised to 9j. Now find out f dot dr and integrate it from 0 to 1, the limit of t. So it will be 0 to the integral 0 to 1, 2t square plus 3t raised to 4 plus 3t raised to 13 dt, which is equal to, yeah. This is a simple integration. You will get it is equal to 1.48. Yeah, exactly 1.5. Yeah. Sometimes in question paper they may specify the number of decimal points. So sometimes they may say you have to write the answer. You have to give the answer up to correct up to 2 decimal points or 3 decimal points or 1 decimal point. So you have to answer it according to that by approximating it. Okay. So if the answer is asked for correct up to 1 decimal point in this case, you have to make it into 1 decimal point. By approximating, you will get it as equal to 1.5. Okay. Okay. So I hope it is clear. Is there any mistake? Somebody is telling something. Yes, where is the mistake? Somebody tell me, is there any mistake? Whatever I have done? Two t square, correct? 3t raised to 4. Oh, yes. That may be a typing mistake. I think the values are correct, right?
Sir, it's 1.51 or something. Actually, I get it in the rational form. It's 91/60.
Okay, 91/60. So maybe I made some mistake in this calculation. I have got t raised to 13 here. So yeah, so that is the mistake. T raised to 13. It is actually t raised to 11, right? T raised to 11.
Yes,
Okay.
sir.
Yeah, okay, fine. Thank you. So anyway, okay, sorry for the mistake. So anyway, that is you know how to calculate that, right? Okay, so what is the actual value? Somebody tell me.
So it's 1.516.
Okay, 1.516. So you can write it as 1.5 or 1.51, whatever it is. Okay. Right. Oh, wow. Oh, no. 1.5 or 1.52. That will be correct. Okay. Right. So sorry for the mistake once again. Okay. Anyway, is that clear? The method of finding this line integral. Okay. Right. So let us move on to the next question. Okay. Next question is, let F be the vector field AYI plus ZJ plus XK and C be the positively oriented closed curve given by x square plus y square is equal to 1 and Z equal to 0. If the line integral F dot dr over C is equal to pi, then the value of A is. Again, you've got a question in line integral. So first thing you have to do is parameterize the curve. Then after that, uh, convert everything into the parametric form. Then you just find out f dot dr and integrate. Yes, I can see somebody got the answer. Okay, so I think we don't need to waste much time. So let us go to the answer. So here again, I have parameterized the curve as a cos theta I plus a sin theta j and z equal to 0. Dr is again, sorry, once again, let me look at the question. It is not a cos theta, it is cos theta I plus sin theta j. A is equal to 1. The radius is 1. So cos theta I plus sin theta j. So dr is minus sin theta I plus cos theta j. So the f in the form of in the parametric form is a sin theta. A sin theta I plus 0j plus cos theta k. Now f dot dr is given as pi. So find out f dot dr and equate it to pi. You will get pi is equal to integral 0 to pi minus a sin square theta. F dot dr is minus a sin square theta plus 0 plus 0. So minus a sin square theta d theta. On integrating it, you will get this equal to minus a pi. So you are getting a pi equal to minus a pi. So that implies a is equal to minus 1. Okay. Yeah. Some of you got the answer. So is that clear?
Yes, sir.
Okay, fine. So let us move on to the next question. Yeah, this is again about line integral. So let me see if we have time. We can see that question. But before that, let me tell you something. Work done by a force. So sometimes there will be a question like this. So here the question is, you have given a force field and a path. Path is the intersection of the cylinder y equal to x square and the plane z equal to x. From point 0, 0, 0 to 1, 1, 1 along the curve. Then you have asked to find out the work done by the force. So work done by the force is nothing but the line integral f dot dr. Okay, so that is what you have to find out. So that I think you can do that. Let me move on to the next topic, which is next question. So we will do the 10th question if the time permits, because it is just the same as line integral we were doing here. So next question, consider the vector field f is equal to xi plus yj on an open connected set, which is a subset of R2, S subset of R2. Then which of the following statements are true? First statement, divergence of f is 0 on S. Second statement, the integral of f is independent of the path in S. The vector field f can be expressed as a gradient of a scalar field in S. Last option is the line integral of f is 0 around any piecewise smooth closed path in S. So you have to find out the true statements from the following. So before that, let us recall something which is called path independence. If f is a vector field defined on an open region D, suppose that for any 2 points A and B in D, the work done, as I was telling, the line integral work done, integral A to B f of f dot dr, which is done in moving A to B, moving from A to B, is the same over all paths from A to B. That is, work done for moving from the point A to B is same for every path which joins A and B. Okay, if you move from A to B through any path, the work done will be the same. So such a case is said to be path independence. So that work done is independent of the path, or in mathematically the line integral is independent of the path. So that is the idea of path independence. So the field which gives path independence, or which satisfy path independence, is called a conservative field. Okay, such a field is called conservative field. So it depends on field. So some fields will be path independent and some of them will not be path independent. So mathematically speaking, it is the conservative field is a field whose line integral from the point A to B over any path is the same. Okay, so that is what conservative field and path independence. And a potential function for a vector field is a scalar field f, small f, on D, which satisfies the condition that the vector field f is the gradient of that scalar field. Okay, so if a vector field can be represented as a gradient of a scalar field, then that scalar field is called the potential function of the given vector field. Okay, next you have fundamental theorem of line integrals, which states like this: f is a vector field mi plus nj plus pk, whose components means m, n, and p are continuous throughout an open connected region D in the space. Then there exists a differentiable function f such that f is equal to del f, which is the potential function. F is the potential function if and only if for every point A and B in D, the value of the line integral A to B f dot dr is independent of path joining A and B. That means f is path independent. So simply the theorem says a vector field f has a potential function, or a vector field f can be represented as a gradient of a scalar field if and only if that vector field is conservative. Okay, vector field is conservative. If the integral is independent of the path, from A to B, its value is given by integral A to B f dot dr is equal to f of B minus f of A. Here, the small f denotes the potential function. Okay. Next, let f be a vector field on an open connected region D, then the following are equivalent. Integral over C f dot dr is equal to 0 around any closed loop in D. The second statement is the field f is conservative on D. That means integral, the line integral of f around any closed loop is 0 if and only if the field is conservative. That is the theorem says. Okay. Now, how to find out or how to verify whether a given vector field is conservative or not? So, suppose you have given a vector field f equal to mi plus nj plus pk, where m and n are functions of three variables x, y, and z, having continuous first partial derivatives. Then the field f is conservative if and only if my is dou my dou y is equal to nx, nz equal to py, and mz equal to px. This is the condition for being f conservative. Okay. So this is the idea you have to use for this question. The idea of path independence and conservative fields. Okay, so now you can answer the question. So some of you have got some answers. Okay. So use those facts to conclude which are the which of the statements are true. Okay, let us move on to the answer. So can we move on to the answer? Yes. Okay. Okay. Let us see. Yeah, the given vector field is xi plus yj. Here m, the component m is x and n is y. So my is equal to 0. Nx is also 0. So my is equal to nx. We don't have a component for z. Third component is not there. So thus the given field is conservative. So there exists a scalar field. So if the field is conservative, then you can see there exists a potential function for that. So that means there exists a scalar field small f such that the vector field f is equal to gradient of the scalar field. So divergence of f is del dot f. Del dot f is equal to del dot f will be 2. You can calculate it because yeah, del dot f means dou x by dou x by dou x by dou x plus dou y by dou y. So it will be 1 plus 1, which is 2. So it is not equal to 0. So first option was divergence is 0 on S. So divergence is not 0. So option A is not correct. Now, since f is a conservative field, by definition, its integral should be path independent. Its line integral should be path independent. So, what option B says, the integral of f is independent of the path in S. Correct. It is true. B is also correct. It is path independent. Now, third option is F can be expressed as a gradient of a scalar field. It is correct because F is a conservative field, so F can be represented as a gradient of a scalar field. Now, last option, option D, says the line integral of F is 0 around any piecewise smooth closed path in S. We know that since F is a conservative field, line integral over F or line integral of F over any closed path is 0. So option D is also correct. So the correct options are B, C, and D. Okay. Okay. Is that clear? So just use the idea of conservative fields, right?
Yes, sir.
Okay. We'll move on to the next question. Okay. Yeah. Next question is this: if C is a smooth curve in R3, which connects the points -1, 0, 1 to 1, 1, -1, then the value of integral 2xy plus z square dx plus x square plus z dy plus y plus 2xz dz is. So I need to find out the integral of the value of this integral. So you can do it. C is given as a smooth curve in R3, which starting from the point -1, 0, 1 to the point 1, 1, -1. So then I need to find out the value of the given integral. Okay, some of you got answers. Okay, somebody who got the answer can explain. Can you explain? How did you get the answer? How did you do that question?
Sir, we can find the potential function.
Correct. So how did you end up in that option? Means like it is going to be a conservative field or something. From where did you get the idea that it's going to be a conservative field? So can you just tell me?
Sir, the curl F is 0.
The curl f is 0. So you found out curl f, right?
Yes, sir.
Okay, fine. Okay, that's a good move. So can we go to the answer? Right? Yes, I think. So yeah, so here is the answer. So anyway, so that was a good move that she was explaining. She just found out the curl of this vector field f. So if the curl is 0, then you can say that the field is conservative. Other way, it's like, see the question. The question was telling C is a smooth curve in R3 from -1, 0, 1 to 1, 1, -1. So it did not say what is the exact path. So from that you can have a notion, or you can have a intuition that this may be a conservative field, because It should be path independent. Otherwise, you have to specify the path. If the integral is not path independent, we have to specify the path. So there is a chance for the field being conservative. So that is how you have to get the idea of conservative field here. Then you can check for curl of f, right? So anyway, this field is conservative. Now, yeah, you can check whether the field is conservative or not by curl f or by the component test, whatever it is, Now the thing is that you have to find out its potential function. Then only you can find the integral, because you know that by fundamental theorem of line integrals, once the field is conservative, integral a to b f dot dr is equal to f of b minus f of a, where small f denotes the potential function of f. Okay, so now we need to find out f. So how to find out f? So the components of f are given by, this field f are given by m is equal to 2xy plus z square, n is equal to x square plus z, and p is equal to y plus 2xz. So using these components, you have to find out the potential function. So once you have a potential function f, then the vector field is dou f by dou xi plus dou f by dou yj plus dou f by dou zk. So m is actually fx, which is dou f by dou x, n is fy, and p is fz. So using these facts, you have to find out the potential function. In most of the cases, you can guess the function. So here you see fx is 2xy plus z square, fy is x square plus z. So fz is y plus 2xz. So from these three, you can get that the potential function should be x square y plus yz plus xz square by looking at the components or the partial derivatives. Otherwise, you have to integrate f of x, and in that way you have to find out. Sorry, integrate fx and represent it as some function plus the integral plus a function of y and z. Then again differentiate it with respect to y and equate it to fy. Then find out the value of that extra function, and so and so. So in most of the cases, you can find out the potential function by just seeing the partial derivatives. Okay, so here you are getting it is x square y plus yz plus xz square. So then it is very easy. Integral over c f dot dr is equal to f of 1 1 minus 1 minus f of minus 1 0 1. Those are the points given. So we'll get the value is 2, which is option C. Is that correct? So I hope all of you got the same answer, right? Yeah, C. Okay, so it is all about understanding. This question is about a conservative field. Okay. So this question, I will just show you the question. This is again a question for conservative field. Let f is equal to 2xyz e raised to x square I plus z e raised to x square plus y e raised to x square k be the gradient of a scalar function. From that, you can understand that this is a conservative field because it is a gradient of a scalar field. The value of the line integral f dot dr along the oriented path L from 0 0 0 to 1 0 2 and then to 1 1 2. Actually, you have to find the integral from 0 0 0 to 1 1 2. That in between point 1 0 2 you can ignore because the field is conservative, so the integral is path independent. So here also you have to find out the potential function. The potential function will be just looking at fx is 2x y z e raised to x square. z e raised to x square is fy, fz is y e raised to x square. By looking at these three, you can guess the function and the potential function, and then you can find the answer. Okay, the potential function will be yz e raised to x square, I think. Yz e raised to x square. So from that you can find out the value. Okay, so that is we can next question. Okay, this is all again a question from conservative fields. U as the field given by this, where where the a represented here is a constant. If the line integral over any closed curve is 0, then the value of a. So they have asked the value of a. So again, since the line integral over every closed curve is 0, it is a conservative field. So you can use the concept of conservative field. You can find the value of a. Okay, so do this question then. So we have to find out the value of a from this question. Means yeah, from this condition. Yeah, correct. So some of you got the answer. Yeah. Actually, what you need to do is, it is a conservative field. Then curl of that curl is 0. Curl of this field will be 0 for a conservative field, because we have already seen that curl of del f is 0. Curl of gradient is 0. So once u is a conservative field, then you can be represented as gradient of some scalar field. So curl of u will be curl of gradient of some scalar field, which will be equal to 0. So you can find out curl of u and equate it to 0. You will get the value of a. Okay, so the value of a here, yeah, so curl of u equal to 0. By equating that, you will get the value of a equal to 1. Okay, so that is the way to find out. Next question. Let C denote the boundary of the semicircular disk be equal to ordered pair xy such that x square plus y square is less than or equal to 1 and y greater than or equal to 0. And let phi of xy is equal to x square plus y for xy and t. If vector n is the outward unit normal to C, then the integral over C del phi dot n ds evaluated counterclockwise over C is. So you have to find out the value of the integral. So the answer, yeah, somebody got the answer. So shall we move on to the answer? Or do anybody want to explain it? Okay, I think we can move on to the answer. So here the curve is, the given curve is f of xy, the boundary of the unit disk. So which is f of xy is equal to x square plus y square minus 1 for, so not c, that is something else. It's just f of xy is equal to x square plus y square minus 1. So the unit normal outward to the surface will be del f by mod del f. So the f is this curve. So that is 2xi plus 2yj by 2. Mod del f is 2, just 2, which is equal to xi plus yj. So this is the value of n here. Now we will parameterize the given curve C as cos t and x equal to cos t and y equal to sin t, which is the circle. So now phi of xy is x squared plus y. It is given as x squared plus y. Now you can find out del phi. Del phi is 2xi plus j, which is in parametric form, it is 2 cos ti plus j. N is in the parameter, n is actually xi plus yj, so it is cos ti plus sin tj in the parametric form. Now you can find out del phi dot n. So del phi dot n, integral over c del phi dot n ds is integral 0 to pi. Why did I choose pi? Why did I choose pi? So the boundary is given for a semicircular disk. So the disk is semicircular. So I have to choose up to pi only. So integral 0 to pi of del phi dot n ds, which is integral 0 to pi 2 cos square t plus sin t dt, which is integral 0 to pi 2 cos square t can be written as 1 plus cos 2t plus sin t, which on integrating you will get pi plus 2. So the correct option is D. Okay. Is that clear?
Yes, sir.
Okay, fine. So we'll move on to the next question. Next question is the area of the parameterized surface S is equal to ordered triplet 2 plus cos u times cos v, 2 plus cos u. The first coordinate is 2 plus cos u cos v. Second coordinate is 2 plus cos u times sin v. Third coordinate is sin u in R3, where 0 less than or equal to u less than or equal to pi by 2 and 0 less than or equal to v less than or equal to pi by 2 is dash. You have to give the answer correct up to 2 decimal places. So you have to find out the area of the parameterized surface. The parameterization is given here, correct up to 2 decimal places. So let us see how to find out surface area. Let us recall. The area of the surface f of xyz equal to c over a closed and bounded plane region R is given by double integral over R modulus of del f by modulus of del f dot p dA, where p is the unit vector normal to R and del f dot p not equal to 0. So I have got a picture here. So this S denotes the surface, and here R is the bounded region. The projection of S. We have to find out the surface area about this region. Okay, about this region. So this is the picture. So you have to find, you have this P denotes, the vector P denotes the unit normal, a vector which is normal to this region R. Okay, the projection of that region, so that surface. So this is the formula for finding out surface area. And for a parameterized surface, once the surface is given in a parametric form, that is R of uv is equal to f of uv I plus g of uv j plus h of uv k. It is said to be smooth. I hope you know what does mean by a smooth curve. Smooth if its partial derivatives Ru and Rv are continuous, and Ru cross Rv is never zero on the parametric domain, means domain of the parameters. Then the surface area of such a smooth surface is given by A is equal to integral C to D, integral A to B, modulus of Ru cross Rv du dv. Okay, this is the formula for finding surface area for a parameterized surface. Okay, this is for a non-parametric surface. This formula is for a parameterized surface. Now, how to find out a surface integral? If R is the shadow region of a surface S defined by the equation f of x, y, z is equal to C, and G is a continuous function defined on S, then the integral of G over S is the integral double integral over R G of x, y, z d sigma, where d sigma, R is the bounded region, bounded shadow region of S. That means the projection of S, and d sigma is the surface area differential, and it is given by d sigma is equal to del f by mod del f dA. Okay, dA is the area differential. For a parametric surface as above, we have just discussed about parametric surface. So for a parameterized surface, d sigma is calculated by the formula modulus of Ru cross Rv du dv. So these are the things you have to remember while doing this problem. Okay. So you can do it. So I think that question you need to do some calculations. So anyway, we have given a parameterized surface, so you can use the parametric form of the surface area, parametric form, right? So shall we move on to the answer? I'm not seeing anybody responding. I think that will take time for calculating that partial derivatives and the value of T sigma and all. So let us move on to the answer. So as I was telling here, the surface is given in a parametric form. So you are getting the parametric form of the. I'm just writing it in a nice way. R of uv is equal to 2 plus cos u cos vi plus 2 plus cos u sin vj plus sin u k. So this is the parametric form of the given surface, where 0 less than or equal to u less than or equal to pi by 2, 0 less than or equal to p less than or equal to pi by 2. The surface area for a parameterized surface is given by A is equal to integral. For this particular surface, the area is integral 0 to pi by 2, again integral 0 to pi by 2, modulus of Ru cross Rv du dv. So this is the surface area, the formula for surface area. So you have to find out Ru, Rv, and Ru cross Rv, then modulus of Ru cross Rv. So this much you have to do. So Ru is actually, by calculating, you will get minus sin u cos vi minus sin u sin vj plus cos uk. So that is the value for Ru, and for Rv you will get minus 2 plus cos u times sin v I plus 2 plus cos u times cos v j, there is a j, I missed it, plus 0k, plus 0k. So this is the value for Ru and Rv. Then Ru cross Rv, finally you are getting some great expression, minus cos u cos v times 2 plus cos u I minus cos u sin v times 2 plus cos u j minus sin u cos square v times 2 plus cos u plus sin u sin square v 2 plus cos u k. So this is the value for Ru cross Rv. By finding the modulus of Ru cross Rv, you will get 2 plus cos u, because you can, each term contain 2 plus cos u. So square of that will come out from the square root, so that you will get 2 plus cos u times square root of something. So inside you will get terms involving cos square u, sin square u, cos square v, sin square v, something. So everything will add up to 1. So you will get finally modulus of Ru cross Rv equal to 2 plus cos u. Please do the calculations by your own. There are many terms, but this is not a very tedious calculation. You will get it very easily. Most of the terms will come out, and you will get the answer very easily. So you are getting modulus of Ru cross Rv is equal to 2 plus cos u. Hence, A, the area is given by 0 to pi by 2, 0 to pi by 2, 2 plus cos u du dv is equal to, by integrating you will get pi plus 1 times pi by 2, which is 6.4998 something. So we have asked for the answer correct up to 2 decimal points. Now by approximating I will get this 6.50. Okay, so that is the, so anybody have a problem with this? Somebody's asking something, why sin u? So what is the problem? Tell me, please tell me. Is that clear? Is that clear?
Yes, sir.
It's clear, right? There is no problem in that. Okay, fine. I hope it is clear. Now we are running short of time, so I will just show you some questions. Those things you can do it. So we are left with yeah. I'll give you the material through Vinod sir. So if you want. So we have left with problems on Green's theorem, Stokes theorem, and divergence theorem. So anyway, those questions will take time for solving. So by the time, sir, can we conclude?
Yeah, we can conclude here. So anyway, let me thank Athul for this session. And now the time for the participants to interact with the resource person. You can ask your doubts or you can share your comments about the class. So all are welcome to share your experience. And anyway, let me thank Athul for having this session. Okay, participants, you can now ask your questions or share your comments.
Hello, sir. I am Dia Shah from West Bengal. I am reading in Ashutosh College in our 5th semester. Sir, thank you for this session, and it's very beneficial for us in the vector calculus or and vector differential uh, calculus. Uh,
Okay, thank you, Dia. Thank you, Dia.
sir,
Others? Yeah.
sir, I have solved the previous year question.
Huh?
Sir, I have solved the previous year questions of GEM in this topic,
Okay.
where I can practice more problems.
Okay. If you have any doubt, you can ask with Adul, especially in the area of vector calculus.
Sir,
Okay,
Uh,
thank you.
Actually, you have you solved all the previous year question papers?
sir, I have solved the previous year questions of GEM.
Okay,
Okay,
good,
so
Dia.
that's very good, and I think uh, all the questions when you collect all the questions, it will be covering all the entire syllabus for JAM. So I hope you will be clear with all the things in the JAM syllabus, right?
Yes, sir.
Okay, so you can collect questions from different books also. There are books called Thomas Calculus and all. So from there also you can get many problems for vector calculus. And many engineering mathematical books like Krasik contains this vector calculus. So you can collect problems from there also.
Okay, sir. Thank you.
Okay, fine. Thank you.
Okay, thank you, Dia. Now, others, please do share your experience. And if you have any doubt, you can ask now. Yes.
Hello, sir.
Yes.
Uh, First of all, thank you very much for this session. I'm
Almost.
അല്ല ഉണ്ണീഷനോ ദേവുവിനെ
And appa കഴിഞ്ഞു.
ആ ദേവ് ആണെന്ന് പറഞ്ഞോ മോനെന്നാ അതെ ഓനെ പറഞ്ഞോട്ടെ.
Hello, Shubham.
yes, yes.
Okay, you can share your experience.
Okay. So, thank you very much, sir, for organizing this session, and thanks for the for and thanks to the resource person. Thank you very much.
Okay, thank you. Thank you, Shubham Jaiswal.
Thank you, Shubham.
Others?
Hello.
Yes.
Hello. Sir, I'm Sri Lakshmi, third year BSc Maths student from Malabar Christian College, Calicut, Kerala. The class was very much beneficial. You gave the theory behind each questions, and the questions that you have chosen is very good. Actually, I don't know much about this conservative force potential functions and all. So thank you. It was very beneficial. Thank you for your effort.
Okay,
Thank
thank you,
you. Thank
Sri
you,
Lakshmi.
Sri.
Okay, any others? So if there is no others, we can wind up here. So once again, I would like to thank Atul for being with us for this session. Okay, I wish thanks to everyone attended this program. Okay, let us wind up here. Atul,
Yes, yes, sir.
I will call you later.
Okay,
Now
okay,
let us
sir.
wind up the session. Okay,
Okay,
thank
sir.
you.
Okay. Thank you. Thank you for calling me for the session. Thank you very much.